Let's get started with part 3 of Lab 6, where we're going to look at contouring an area that has streams in it and then calculating the stream gradient. So for the first part of this map, you're going to actually add some contours and label some contours that are already there. So let's take a look at the map for a minute. So this is a map showing an area. The area shown as these dashed dotted lines. These are all the streams in this area. And as it says in the instructions, the first 3 contours have been added for you. Here's one that kind of comes like this. And the second one comes like this. And the third one comes like this. Your first task will be figure out what value these contours have. So some of this, for example, this contour is somewhere between 110 and 83, right? Because it's between those 2 known points there. Once you know the contour values, you'll label each of these contours. You just have to do it once on each contour. And then you'll report what the contour interval is. And then you're going to start contouring the rest of this map. As you contour the rest of this map, remember the rule of V's, right? And that is that the contours, as they approach a stream, they're going to V or point in the upstream direction. So let's just go ahead and see what a 120 contour would look like on this map. And I'll put it on in black. So if we were going to make a 120 contour on this map, we're going up in this direction and there's no indication there's a 120 higher than here. There's no more data points to tell us, but we definitely have some 120s on this side. We have a point here, we have a point here, closer to 125 than 110. We would also have one somewhere in here and somewhere over here as well. So let me just kind of draw on that part here first. I'm just going to start it at the edge of the map because once again, there's no evidence we have 120 on that side of the map. And I'm going to draw my line here, through here, through here. And then where does it go? It has to stay below these 140s. There is another 120 over here, but we have to get to it. And here's another 120. And there would be a 120, somewhere halfway between these two as well. So what you want to do with this is you want to follow the overall pattern of the contours that are already there. You want to V upstream. So we know that this contour line has to V upstream. Then it turns around and it starts coming in this direction here. But before it can get over here, it has to V up this stream as well, just like this one does. So now we'll kind of bring it down like this, kind of come over like that. Go through these 120s here. We have a 122 here. We're going to be very close to 120 around here and between these two. And that kind of makes a natural V as well. Okay. And between here and here, we have to have a 120 somewhere in there. So your contour might do something like that. So you can see it's kind of taking on the shape of the contours that were already there, where we're just kind of working our way up the slope. And then at the very end, you might be just closing off some contours against the edges there. But you'll go ahead and continue that. That'll be the first part of this lab. And then you're going to determine the gradient between point A and point B. So here's point A and here's point B. So to determine the gradient, you have to know what the elevation is at point A. And once you get all your contours on, you'll be able to estimate that. You have to know what the elevation is at point B. And once again, with these contours on, we know it's somewhere below 55. You'll be able to estimate that. And then you have to measure this distance. And this distance is not a straight line. Before when we looked at gradient of elevation of slope, we were able to use straight lines. But now we're going to have to measure that distance along a curved line instead. So in order to do that, you can use this piece of paper. You can use this piece of paper at the bottom, but you're going to have to rotate it in order to get it lined up with each individual segment here. So for example, the first segment is something like that. You want to move it on there, put a little tick on or something, indication where it moves, then take it somewhere else, and then you want to twist it down so you can measure the next kind of straightish line segment, and keep doing that, working all the way from end A until end B. And that's going to give you the distance between A and B. And then once you have the change in elevation and the distance, you're able to calculate the stream gradient. Once you have all your contours on, also you'll be able to see where between A and B the contours are most closely spaced, like these two are apart by a distance of this much, these two are apart by a distance of this much. Maybe that looks like a slightly shorter distance. You'll be able to see which two are the most closely spaced. That's where the stream gradient would be the steepest. And you'll also be able to look at where the stream gradient is the gentlest. That would be where the contours are most far apart.